Welcome back everyone. So today I picked up a problem from modern physics from Shashi Tiwari sir's book. As you can see, it's question number 56 and I guess it's from level 2 of the chapter named Wave Particle Duality and Atomic Physics. Anyway, the problem states that an equilateral glass prism kept on a table has refractive index of mu equals to root 2. It is illuminated by a narrow laser beam having power P0 and wavelength lambda. The path of the laser beam inside the prism is parallel to the base of the prism, so obviously it's a minimum deviation case. Calculate change in weight of the prism due to the incident laser beam. Okay. So as it's equilateral glass prism, all the three angles will be 60 degree and this angle will also be 60 degree corresponding angles because the light ray inside the prism is parallel to the base. We have given this information. I'm drawing a perpendicular on this face. This is the normal on this face. So if this is 60, this angle will be 30 degree and 30 degree will be the angle of refraction for refraction in this left face, right? So inside the prism mu is equals to 2 and outside its mu equals to 1. So if this is angle of incidence, let's say I, we can easily find out I using Snell's law. It is sine I into 1 is sine 30 degree into root 2. So sine 30 degree is a half, so this will come out as 1 by root 2. So I will be 45 degree. I is 45 degree. So this angle will also be 45 degree as this is normal on this surface. And next I am extending this line, incident line. This is a line of incidence, I can call it like this. Then yeah, this angle will be 45 degree also, vertically opposite angle, right? If this is 45, or let me mark it with some other colors, so this one will also be 45. If this is 45, this is also 45 degree. And as the whole angle is 60, this one will be 15 degree. And similarly, by symmetry we can say that if we backtrace the emergent ray, this will also make an angle of 15 degree with the horizontal, or let's say this one is 15 degree. Anyway, both the same. So let's say this is the incident, this was the incident ray, this one was having an angle 15 degree with the horizontal, and let's say this is the emergent ray, right? This is also making an angle 15 degree, but it is 15 degree in anti-clockwise sense, sorry, in clockwise sense from the horizontal, and the green one, that is the incident ray, was making 15 degree in anti-clockwise sense from the horizontal, right? So we are done with the directions of the incident ray and the emergent ray. Now let's say for one photon we can assume its momentum as p equal to, let's say, momentum of one incident photon. So, and obviously this will also be the momentum of emergent photon as well. So let me do one thing, let me erase the incident one, just write it as one photon. So this was the initial direction of the momentum and this is the final direction of the momentum, right? Because initially the ray was making this angle, I mean the ray was making 15 degree with the horizontal but anti-clockwise sense, and now finally it will make a 15 degree angle in the clockwise sense. So you can observe a change in direction of the momentum. That means there must be a force that has been acted on the photon by the prism, and from the vice versa we can say that a force has been acted on the prism as well by the photons, right? And let us define n as number of photons incident per unit time, right? So that will be p0 upon p, sorry, p0 upon hc by lambda. We are assuming lambda is the wavelength of the photon, wavelength of photon. So each photon will have energy of hc upon lambda, and p naught is the power, that means energy incident per unit time. So if we divide the total energy per unit time with energy of one photon, we will get the number of photons. And the momentum, we can easily write that it will be h upon lambda from de Broglie hypothesis. So let's substitute h by lambda equal to small p, that is momentum of one photon. So we'll get n as p naught upon small p into c. Okay, let me erase this. This is p naught upon small p into c. So now it's kind of a mechanics question, where this one was the initial direction of momentum whose magnitude was also p, and this one was the final direction of momentum, this magnitude was also p, and this angle was 15 degree. So if you take the components, I mean the horizontal, let me draw the separate diagrams for the initial and the final. Let's say this one was p initial, this was 15 degrees, so it has two component. This magnitude was p, so this was p cos 15 degree, and the vertical one was p sin 15 degree. And let's say this is the final momentum, its magnitude was p, so it has a horizontal component of p cos 15, and this one was p sin 15 degree. So you can clearly observe that p cos 15 degree has remained unchanged in horizontal direction, but in vertical direction there was p sin 15 degree in upward direction, now in p sin 15 degree downward direction, right? So there is a change in momentum, so I'll write the change in momentum, its magnitude will be 2p sin 15 degree, and it is in downward direction. This is for the photons, right? Change in momentum for the photons. So the force acting on the photons will be force, and this is obviously for one photon. Let me clarify this. So force acting on photons, or the laser beam, whatever you can call, will be 2p sin 15 degree. This is momentum, change in momentum for one photon, and in unit time we have found out here, this is the number of photons incident per unit time. So let's multiply this with p naught by pc. So this one is the number of photons incident per unit time, and this is a change in momentum for per photon. So we'll get change in momentum per unit time, and that is obviously the force. So this is the force, p gets cancelled, this will be 2p naught sin 15 degree by c, and obviously this is acting vertically downward. So from Newton's third law you can clearly claim that the force acting on the prism will be of same magnitude, but the direction will be reversed. The force acting on the prism will be 2p naught sin 15 degree by c. So that is against the gravity, as you can clearly see it is upward direction. So we'll just say that the weight of the prism will get decreased by this amount, right? So I'm just writing here, weight of prism gets decreased by this amount. So that's the answer. I mean, they asked us to calculate the change in weight, so you can just report the magnitude of change in weight, not the increment or decrement, or you can clarify also that this is the decrement in weight. Anyway, so that's all for today. Thank you.